This stone looks dead until the light moves. One angle shows nothing. The next angle breaks white light into color. No paint, no dye, no camera trick, just hidden structures inside the mineral, bending light in ways the eye is not ready for. Some flash like frozen fire. Some open like a secret window. Some look almost engineered. Precious opal became famous for this illusion, but these 10 minerals prove something stranger. Opal was never the only stone that knew how to split light, and number 10 is so quiet most collectors would walk right past it. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10th. Iris Agate, the hidden rainbow. Hold iris agate under normal light and it may not look like a miracle at all. That is exactly what makes it dangerous to underestimate. At first glance, iris agate can appear quiet, even plain. A thin slice of banded chalcedony with soft lines running through it like frozen waves. No explosive color, no obvious fire, no dramatic flash demanding attention from across the room. To an untrained eye, it may look like just another polished agate slab, but the secret is not on the surface. The secret is hidden in the layers. When iris agate is cut thin enough and light passes through it at the right angle, those delicate internal bands begin to behave like a natural optical filter. White light enters the stone, meets the microscopic rhythm of the agate structure, and suddenly breaks apart into spectral color. Reds, greens, blues, and violets can appear where there seemed to be nothing moments before. This is the first lesson of the countdown. Not every rainbow mineral announces itself immediately. Some make the viewer work for the reveal. That makes iris agate a perfect starting point because it changes the way the entire video should be watched. The color is not paint. It is not dye. It is not a surface trick added afterward. In good specimens, the effect comes from the way light interacts with extremely fine, repeated banding inside the stone. In other words, iris agate does not simply have color. It performs color. That is why collectors who understand optical gemstones look at material like this differently. A thick piece may seem ordinary. A poorly lit slice may seem forgettable. But under transmitted light, the same stone can transform into something closer to a natural rainbow screen. Subtle, delicate, and almost impossible to appreciate from a single still image, and that is the emotional hook. Iris agate is not the loudest mineral on this list. It is not the most expensive, not the most dramatic, and not the one that stops a room instantly. But it introduces the mystery that connects every specimen ahead. Nature can build structures so small, so precise, and so hidden that a stone can split ordinary white light into color. Precious opal became legendary for that kind of optical magic. Iris agate proves the idea begins much earlier, in a quieter place, with a stone that looks simple until light passes through it. But some minerals do not wait for light to pass through them. Some throw the rainbow straight back at the viewer. Ranked 9th. Rainbow quartz, the broken prism. A perfect crystal can be beautiful, but rainbow quartz becomes interesting for the opposite reason. Its power often comes from interruption, tiny fractures, internal stress lines, trapped spaces, and reflective planes hidden inside what appears to be a clear stone. Instead of ruining the crystal, those imperfections can turn it into a miniature light chamber. A beam enters, strikes an internal break, bounces, splits, and flashes back as color. That is why rainbow quartz holds attention so well on camera. It does not need to look rare at first. It can begin as something familiar, a transparent quartz point, a polished crystal, a clean mineral specimen sitting quietly under white light. Then the angle shifts and a thin blade of blue or violet suddenly appears inside it like a secret signal caught between two invisible mirrors. For gemstone audiences, this creates a powerful psychological pull. Quartz is common enough that many viewers think they already understand it. That familiarity lowers their guard. Then the rainbow appears and the brain has to correct itself. The stone was not simple. It was hiding a mechanism. In precious opal, color comes from organized microscopic structure. In rainbow quartz, the drama can come from broken internal geometry. One is famous for order. The other becomes fascinating through controlled disorder. That contrast makes rainbow quartz more than just a pretty crystal. It becomes a lesson in how nature can turn damage into optical beauty. Under macro lighting, the effect can look almost surgical. Color does not spread evenly across the whole stone. It appears in narrow streaks, sudden flashes, sharp internal reflections, and ghost-like bands that vanish when the crystal moves a few degrees. That angle dependence is what makes the viewer keep watching. The stone refuses to reveal everything at once, and there is a deeper reason collectors respond to it. Rainbow quartz makes a flaw feel valuable. A crack that might lower the appeal of one gem can become the very feature that gives another its personality. It challenges the idea that beauty in gemstones must always mean perfect clarity, perfect color, or perfect symmetry. Sometimes the unforgettable part is the scar inside the stone. That is where rainbow quartz earns its place in this countdown. It does not rival opal by copying opal. It rivals opal by creating a different kind of light performance, sharper, colder, more sudden, and more fragile. Then the story turns risky, because the next mineral does not just raise questions about light, it raises questions about trust. Ranked 8th, Chalcopyrite, the collector trap. The most dangerous rainbow in mineral collecting is not always the rarest one. Sometimes it is the one sitting in plain sight at a mineral show, glowing with purple, gold, blue, and electric green under bright display lights. Chalcopyrite can look almost unreal when its surface develops iridescent colors. Its metallic body already carries a brassy shine, but once tarnish, oxidation, or surface alteration enters the picture, the stone can shift into something far more dramatic. That is where the trap begins. To a casual viewer, a rainbow-covered chalcopyrite specimen may look like nature made a perfect metallic gemstone. To a collector with experience, the first question is different. How did that color get there? This is what makes chalcopyrite such a strong entry in the countdown. It is not just a visual mineral, it is a credibility test. Some specimens show natural surface color from alteration. Others may be treated to intensify the rainbow effect, especially pieces sold as flashy peacock ore. The result can still be beautiful, but beauty and natural origin are not always the same thing. That distinction matters for a gemstone documentary audience, because precious opal earns its legend through internal structure, microscopic order creating play of color from within. Chalcopyrite's rainbow often lives closer to the surface, where chemistry, oxidation, and human handling can complicate the story. Its color can be spectacular, but the meaning behind that color depends on honesty. On camera, chalcopyrite works best when filmed like a mystery object. Start with the golden metallic base. Let the viewer see why it has been confused with fool's gold. Then move into the iridescent zones, violet fading into copper, blue sliding into green, patches of color that look almost oil-like across the rough surface. But the narration should not oversell it. The power of this section comes from tension. This is the moment where the video stops being only about beautiful minerals and becomes more mature. It teaches the viewer how collectors think, not just what does it look like, but what caused it. Is it stable? And is it natural or enhanced? That one question raises the stakes for every mineral that follows. Chalcopyrite deserves its place because it reveals a truth many beginners learn too late. Rainbow color can be stunning, but not every rainbow tells the same story. Next comes a mineral so visually famous that its nickname became more recognizable than its chemistry, a metallic stone dressed in the colors of a peacock. Ranked 7th, Bornite, the peacock illusion. Few minerals earn a nickname before most people ever learn their real name. Bornite is one of them. To collectors, it is often known as peacock ore, and the name makes sense the moment light touches it. Across its metallic surface, color can bloom in waves of blue, violet, magenta, bronze, gold, and green. It does not shimmer like a faceted gemstone. It does not glow like opal from deep inside. Its effect is louder, stranger, more industrial, as if a piece of metal has been stained by a rainbow. That visual shock is exactly why Bornite belongs here. But Bornite also needs careful storytelling because its beauty sits in a complicated place. The fresh mineral itself is usually more bronze-brown to coppery in appearance. The famous Peacock colors often develop from surface alteration and tarnish. In the mineral trade, some specimens are also enhanced or confused with treated Chalcopyrite, which is why experienced collectors look beyond the first flash of color. This gives Bornite a different kind of narrative power. It is not the innocent hidden rainbow of iris agate. It is not the delicate broken prism of rainbow quartz. It is not only a collector warning like Chalcopyrite. Bornite is the showman, the mineral that walks into the frame already wearing the costume. On screen, it should feel bold and slightly suspicious. A macro shot can move slowly across the surface, letting the color shift like liquid metal. Purple edges fade into blue. Gold patches break through darker oxidation. A rough crystal face catches the light and suddenly the surface looks less geological and more manufactured, almost too vivid to trust. That tension keeps the viewer engaged, because the central question is no longer simply, how does nature make color? The question becomes, when color is this dramatic, where does natural beauty end and surface transformation begin? Compared with precious opal, Bornite is almost the opposite kind of spectacle. Opal's play of color feels internal, delicate, and gem-like. Bornite's rainbow feels external, metallic, and unstable, a skin of color telling the story of chemistry, time, exposure, and sometimes human interference. Yet that does not make it less fascinating. It makes it more layered. Bornite proves that iridescence is not one single phenomenon. Sometimes the rainbow is hidden inside a structure. Sometimes it flashes from fractures, and sometimes it lives on the surface like evidence left behind by the mineral's reaction with the world around it. The next stone shifts the mood completely. No metallic disguise, no marketplace confusion, just a brown, earthy gemstone hiding fire beneath its skin. Ranked 6th. Fire Agate, the buried flame. Brown is not usually the color that stops a gemstone collector. That is why fire agate has one of the most satisfying reveals in the mineral world. At a distance, it can look earthy, uneven, even slightly strange. A surface of rounded bubbles, dark honey, rust, chocolate, and reddish-brown layers. Nothing about that first impression screams rainbow. It does not arrive with the electric flash of Labradorite or the metallic spectacle of Bornite. Fire agate plays a slower game. Then the light moves. Suddenly, beneath that quiet surface, color begins to wake up. Green appears first, then orange, gold, red, and sometimes flashes that feel almost liquid. The effect does not sit flat on top of the stone. It seems buried just under the skin, like a trapped ember glowing below transparent chalcedony. That is the emotional strength of fire agate. It feels discovered, not displayed. For a mature gemstone audience, this matters. The appeal is not just pretty color. It is the feeling of looking into a natural object and realizing there is another world underneath. The rounded botryoidal forms create depth. The thin internal layers catch light unevenly. The result can look like flame moving under glass, especially when the stone is rotated slowly under a single controlled beam. This is where the countdown becomes more gem-like and more intimate. Chalcopyrite and Bornite gave the story a metallic, suspicious edge. Fire agate brings the viewer back into the emotional heart of gemstones. Patience, cutting skill, hidden value, and the moment when rough material finally reveals what it was protecting. But fire agate also teaches an important lesson. Its beauty depends heavily on angle, polish, thickness, and lighting. A weak specimen may appear muddy. A strong one can look alive. That difference is exactly why serious collectors study the stone instead of judging it in one glance. Compared with precious opal, fire agate creates a different kind of performance. Opal often scatters color in bright patches and shifting patterns. Fire agate feels deeper, warmer, and more volcanic, less like a rainbow across the sky, more like a coal still burning after the fire has gone out. Its place at number 6 is earned because it changes the emotional temperature of the video. The rainbow is no longer just light physics. It becomes heat, depth, and hidden flame. Ahead, the color does not burn from below. It appears like a door opening inside gray stone. One angle dull, the next angle electric. Ranked 5th, Labradorite, the sleeping window. Turn Labradorite too quickly, and its magic can disappear. That is the strange power of this feldspar. It does not perform from every direction. It does not reward careless viewing. Under flat light, Labradorite may sit quietly in the hand as a gray, smoky, greenish, or dark stone with very little drama. For a moment, it can look almost asleep. Then the angle changes by only a few degrees. A blue flash opens across the surface. Not a small sparkle, not a scattered glitter. A broad sheet of color can suddenly appear, as if someone switched on a hidden screen inside the mineral. In stronger pieces, that flash can deepen into electric blue, teal, green, gold, or even orange. The stone seems to contain a landscape. Storm clouds outside, northern light trapped within. This is why Labradorite works so well at the center of the countdown. It is familiar enough that many viewers have seen it before, but mysterious enough that most have never understood what they were seeing. The effect is called labradorescence, and it comes from light interacting with extremely thin internal layers inside the feldspar. Instead of color coming from pigment alone, the stone uses structure. Light enters, meets those hidden planes, reflects, interferes, and returns as a glowing flash that only appears from certain angles. That angle dependence is the hook. Labradorite almost behaves like a locked room. From one position, nothing remarkable happens. From another, the door opens and the stone reveals a blue world behind the gray. This makes it emotionally different from fire agate. Fire agate feels like heat rising from below. Labradorite feels colder, wider, more cinematic, like a window suddenly opening into an Arctic sky. For collectors, the best pieces are not judged only by color, but by strength, coverage, direction, and contrast. A weak flash may appear in a small corner. A powerful specimen can light up across the entire face. That difference is what separates a decorative stone from one that makes people stop and turn it again. Compared with precious opal, Labradorite is less chaotic and less fiery. Its beauty is broader, smoother, and more atmospheric. Opal flickers like scattered sparks. Labradorite often opens like a single sheet of light. At number 5, the countdown reaches its midpoint with a mineral that teaches one of the most important truths about rainbow stones. Sometimes the color is not hidden deep. Sometimes it is waiting for the viewer to stand in exactly the right place. The next stone takes that same feldspar mystery and makes it darker, sharper, and far more theatrical, closer to a frozen aurora than an ordinary gem flash. Ranked 4th, Spectrolite, the Northern Lightstone. Spectrolite feels like Labradorite after the volume has been turned up. The relationship is important, but the storytelling cannot treat it like a repeat. Labradorite introduced the idea of a gray feldspar suddenly opening into blue light. Spectrolite takes that same family of optical behavior and gives it a more dramatic personality. Darker body tone, stronger contrast, sharper flashes, and a wider feeling of color when the specimen is exceptional. This is why it deserves its own place near the top. A strong Spectrolite specimen does not simply flash. It stages a reveal. Deep blue can cut across the surface like frozen lightning. Green can follow behind it. Yellow, orange, and violet may appear in separate zones, turning the stone into something that feels less like a single color effect and more like a storm trapped inside polished rock. For an American gemstone audience, this is where the video should slow down just enough to let the image breathe. Spectrolite has that premium collector energy. It does not need exaggerated claims. Its strength is visual authority. The stone looks serious before it looks beautiful, dark, controlled, almost silent, and then the color arrives with the force of an aurora breaking through cloud cover. That contrast gives Spectrolite its emotional identity. Labradorite feels like discovering a window. Spectrolite feels like standing in front of the whole sky. Its iridescent display comes from light interacting with internal feldspar structures, but the viewer does not need a lecture to feel the effect. The important idea is simple. The stone is not glowing because color was poured into it. It is redirecting light through hidden architecture. Under the wrong angle, the beauty collapses. Under the right angle, it becomes theatrical. That makes Spectrolite powerful for retention because it rewards motion. A still photo can look impressive, but video reveals the real behavior. As the camera tilts, color appears, disappears, slides, and reforms. The viewer keeps watching because the stone seems to be making decisions, withholding one flash, revealing another, then going dark again. This is also where the countdown starts feeling more elite. The minerals below it were fascinating for their surprises, warnings, fractures, and hidden flames. Spectrolite raises the standard. It feels less like a curiosity and more like a centerpiece, the kind of specimen that makes a collector pause before asking the price. Yet the next mineral breaks that elegance completely. After the northern light beauty of Spectrolite, the story drops into something rougher, darker, and stranger. An iron-rich surface that looks less like jewelry and more like a fragment from another planet. Ranked third, Rainbow Goethite, the alien surface. Iron is supposed to feel familiar. It rusts, it stains, it darkens. It turns soil red, gives cliffs their color, and appears in some of the most ordinary-looking rocks on Earth. But in Rainbow Goethite, that same iron-rich world becomes something far stranger. A rugged mineral surface washed in metallic purple, bronze, green, blue, and deep red, as if the stone has been exposed to light from another planet. This is not the smooth elegance of Spectrolite. Rainbow Goethite has a more primitive force. Its surface can look rounded, rippled, and botryoidal, almost like clusters of frozen bubbles or cooled lava. The color does not always appear as a clean flash. It can spread across curves, collect in pockets, darken at the edges, and shift as the camera moves. Under macro lighting, it feels less like a polished gemstone and more like a tiny alien landscape. Valleys of iron, ridges of color, and metallic skin that refuses to stay one shade. That roughness is exactly why it works so well at number 3. After several minerals that reveal beauty through transparency, internal layers, or clean optical flashes, Rainbow Goethite changes the texture of the entire countdown. It reminds the viewer that nature does not need perfection to create spectacle. Sometimes the most mesmerizing color comes from surfaces that look weathered, ancient, and almost damaged. The appeal is not luxury in the traditional sense. It is geological intensity. Rainbow Goethite attracts attention because it feels raw. It does not ask to be mistaken for diamond, sapphire, or emerald. It belongs to a different category of fascination, minerals that look like evidence of pressure, chemistry, oxygen, water, time, and transformation. The rainbow is not floating inside a clear gem. It is stretched across an iron-rich surface like a record of what the mineral has been through. That makes it psychologically powerful for a gemstone audience. Collectors often love stones that feel like they carry a story. Rainbow Goethite does that instantly. It looks old. It looks reactive. It looks as if its color was earned, not simply displayed, and because the iridescence can shift across uneven surfaces, the eye keeps searching for the next patch of violet, the next copper streak, the next green flash hiding along a curve. Compared with precious opal, Rainbow Goethite is darker, heavier, and more mineralogical. Opal feels like light suspended in silica. Goethite feels like iron learning how to wear a rainbow, and that is why it earns a top 3 position. Not because it is the cleanest, because it is one of the strangest. From here, the countdown moves from alien-looking surfaces to microscopic architecture. A mineral where the real spectacle may be too small for the human eye to see, but powerful enough to control visible light. Rank second, Rainbow Hematite, the microscopic machine. The rainbow on hematite should not look possible. This is a mineral most people associate with weight, darkness, iron, and a cold metallic shine. Hematite feels dense in the hand. It can appear gunmetal gray, black, silver, or deep reddish brown when powdered. Nothing about its basic identity suggests softness, color play, or the kind of spectral flash usually associated with precious opal. Then a rainbow hematite specimen catches the light. Suddenly, that heavy iron mineral becomes electric. blue, green, violet, gold, and copper can move across the surface with a controlled intensity that feels different from ordinary tarnish. It is not the loose, chaotic beauty of rainbow goethite. It is tighter, sharper, more ordered. The surface can look as if it has been engineered rather than grown, a natural optical device hiding inside a mineral that should have been visually severe. That is the reason rainbow hematite belongs near the top. Its power is not only visual, its power is structural. In the strongest examples, the color is tied to microscopic organization, tiny repeating features on or near the mineral surface that interact with visible light. To a viewer, the result is a shifting rainbow. To a gemologist, the deeper fascination is the idea that nature has arranged iron-rich material at a scale small enough to manipulate light itself. That is the core theme of this entire countdown. These minerals are not simply painted by chemistry. They are shaped by architecture. Rainbow hematite makes that idea feel almost scientific and cinematic at the same time. A camera can start on a dark metallic surface that looks nearly black. Then the light angle changes and color begins to separate across the face. Violet at one edge, green in the middle, bronze along a ridge, blue flickering where the surface turns. The stone seems to process light rather than merely reflect it. For an older American audience that enjoys geology and mystery, this is the moment where the video should feel most authoritative. No hype is needed. The phenomenon itself is strong enough. The narration should make the viewer feel that the real treasure is invisible, not the color alone, but the hidden pattern responsible for it. Compared with precious opal, rainbow hematite has a colder, more metallic personality. Opal feels fluid, delicate, almost alive. Rainbow hematite feels like a machine built from iron, order, and light. That contrast is what makes it unforgettable. By number 2, the countdown has reached the scientific climax, a mineral whose beauty depends on structures too small to see, yet powerful enough to turn a dark iron surface into a controlled rainbow field. Only one entry remains, and it does not win by being louder than hematite. It wins by breaking one of the strongest assumptions collectors have about garnet itself. In first place, rainbow andradite garnet, the opal rival. Garnet carries one of the most familiar names in the gemstone world, and that familiarity is exactly what makes this final entry so unexpected. For many buyers, garnet means deep red. A classic January birthstone, a dark wine-colored gem in antique rings. Beautiful, durable, historic, but rarely described as a rainbow mineral. That assumption collapses when rainbow andradite garnet enters the frame. This is not the garnet most people imagine. In certain rare andradite specimens, iridescent color can appear across the surface in shifting bands and spectral flashes. Instead of relying on the traditional red identity of garnet, these stones create their impact through light behavior. The body may look dark, earthy, or subdued at first, but when the surface catches the correct angle, the gem can flash with colors that feel surprisingly close to the visual language of precious opal, green, violet, blue, gold, and copper, moving across the stone as the light changes. That is why it earns the number 1 position. Not because it replaces opal, because it challenges the mental category that opal owns. Precious opal is famous because it turns light into motion. It does not sit still. It shifts, breaks apart, and reorganizes color as the viewer moves. Rainbow andradite garnet creates a different version of that shock. It takes a gemstone family known for classic body color and reveals an optical side most casual viewers never expect. That surprise is powerful for retention because it pays off the entire countdown. The earlier minerals showed hidden bands, broken prisms, metallic skins, buried fire, feldspar windows, alien iron surfaces, and microscopic machines. Rainbow andradite brings those ideas into a gemstone name many people already recognize, then twists the expectation. A strong visual sequence should begin with the ordinary belief, garnet as a red gemstone. Then the cut should shift to rainbow andradite under controlled lighting. The viewer should feel the contrast immediately. This is not just another pretty mineral. This is a familiar gem family behaving in an unfamiliar way. For collectors, that matters. The best stories in gemstones often begin when a stone refuses to act like its reputation. Sapphire does not always have to be blue. Diamond does not always have to be colorless. And garnet does not always have to be red. Rainbow Andradite earns its final place because it delivers the cleanest payoff to the title, a non-opal mineral that can still create that same impossible question in the viewer's mind. How can a stone do that with light? That question is the real treasure. Opal may remain the legend of play of color, but it is not alone in the natural world of optical wonder. Hidden in agates, quartz, feldspar, iron minerals, and rare garnets are structures that bend, split, scatter, and return light in ways that feel almost engineered. These minerals prove that nature does not simply make color. Sometimes nature builds the machine that creates it. Color in gemstones is not always what it seems. Sometimes it is not pigment. It is structure, a fracture, a hidden layer, a metallic surface, a pattern too small to see. Precious opal may be the legend, but these minerals prove it is not alone. Across the mineral world, ordinary light can become fire, rainbow, metal, or mystery, if the stone is built the right way. And that is what makes these specimens unforgettable. They do not just show color, they reveal how nature creates it.